Let's review. In an earlier lesson, we discussed three factors that affect the solubility of a solid. 1. Solubility is directly related to temperature. 2. The addition of common ions to the equilibrium system of an insoluble decreases solubility. And 3. As a solution is acidified, the solubility of compounds having anions that act as bases increases. Recall that more soluble means greater concentration of floaty ions in solution. And in this lesson, we're going to cover the fourth factor, the last factor, that affects the solubility of compounds, and it deals with complex ions. Let's see what we have here. In the presence of specific Lewis bases, the solubility of insolubles is affected if the metal in the insoluble forms a complex ion with those Lewis bases. There are a couple of terms in this sentence that we need to make sure we understand. First of all, what is a Lewis base? And secondly, what is a complex ion? In one of my earlier lessons, I covered Lewis bases, and a Lewis base is something that provides a lone electron pair. We call Lewis bases, when they become part of a complex ion, we call them ligands. Complex ion is an ion, obviously, that consists of a metal ion and the ligands that are bonded to them. A visual representation of a complex ion might be shown here on the lower right corner of the screen, where in the center we have our metal ion, which has some positive charge. We don't know what it is, so I've just put X there. M stands for metal. And then we have a certain number of Lewis bases oriented around the metal ion. Now here I've shown 4, but it might not be 4. The point is that when a Lewis base becomes part of this thing called a complex ion, we don't call them Lewis bases anymore, we call them ligands. Here are some typical Lewis bases that turn into ligands. That is, they are in complex ions, and most of these you should recognize. There's ammonia, which has a lone pair of electrons. We have the cyanide ion, hydroxide ion, chloride ion, and water. Of course, in water, the oxygen atom has 2 lone pairs of electrons, which can act as ligands in forming these complex ions. The number of ligands that surround the metal ion is called the coordination number. In this picture on the right side of the screen, the coordination number for that complex ion would be 4. At the top of the screen, you see several complex ions. I see no need to have my students memorize these, but you will note that they have several things in common. One is they're all ions. They all have a net charge. Sometimes it's positive, sometimes it's a negative net charge. They all have a metal atom that is in the center of each of these ions. We have silver, aluminum, cadmium, copper, cobalt, iron, and zinc that I've listed. And you can see that around them they have some Lewis bases, some electron pair providers. There are 3 common coordination numbers, and I bet you can guess what they are just by looking at the complex ions that I've listed at the top. This first compound has a coordination number of 2, and this one has 2, and this one has 4, 4, 4, 4, 4, 4, 6, 6, 4, and 4. So the 3 most common coordination numbers are 2, 4, and 6. Complex ions have geometries that we've met before. Here are some pictures of several of the ions that are actually listed up here at the top of the screen. You can see this one in the lower left corner has a zinc ion in the middle, and then it has 4 ammonia molecules oriented around it, so that would be this ion right here. Ammonia, NH3, has 0 net charge, And you're supposed to know that the zinc ion has a 2 plus charge. So if you take something with a 2 plus charge and connect it with 4 things that have a net 0 charge, then the net would be a 2 plus charge. The one in the middle has a coordination number of 6, and it's this one that's in the upper right corner. It's got the iron 3 ion in the middle, and it's got 6 waters oriented around it for a net charge of 3 plus. The geometry of the one in the lower left is tetrahedral. The one in the middle here is octahedral. This one here on the right is linear, and the one in the lower right corner square planar. Those geometries you should be familiar with from your earlier studies in chemistry. So let's do an example. In a solution of silver chloride, we have this equilibrium going on, where most of the mass, probably, of the silver chloride is in the solid form, with a few silver ions and a few chloride ions being dissolved in the water. If we then add ammonia to that solution, and you can see we've got that right there, we're adding ammonia, and it turns out that ammonia forms a complex ion with these silver ions to form this thing right here. It has a certain name, but I'm not going to go into the nomenclature. I don't ask my students to know that. Maybe your chemistry teacher will expect you to know that. So there are some fairly easy rules for naming these, but I'm not going to go into them. But you can see that in the formation of this complex ion, we are removing silver ion from solution. If we then go to the top of the screen and look at this equation we've written, if we are removing silver ion from this side of the equation, then won't Le Chatelier say that we should shift to the right to try to replenish that? Well, when we shift to the right, what happens to the amount of solid silver chloride that we can see? And the answer is, it decreases. And that's what this sentence says on the right side of the screen. As the silver ion forms the complex ion with ammonia, Le Chatelier predicts more silver chloride will dissolve to replenish decreased concentration of silver ion. You can actually visually see this here on the left side of the screen. This is silver chloride in solution. If we add ammonia to it, if we add enough ammonia, you can see that all of the visible AgCl will dissolve into solution in forming the complex ion. So now we just need to figure out whether an up arrow or a down arrow goes in this blank in the lower right corner. The solubility of insolubles does what in the presence of any Lewis base that the insoluble's metal forms a complex ion with? Increases